What are geometric progressions and what are they used for? To answer this question, let's start with a very ordinary real-life example, the humble paperclip. Suppose that you're an entrepreneur whose company works in the office stationery sector and produces paperclips. Geometric progression can help you plan your production for any period of time in the future. In this case, let's say 1 month. In your production unit, you have an industrial robot that is scheduled to produce a number of paper clips each day that is the equivalent to 3 times the number of paper clips made the day before. Within a month, there are 20 days when the robot makes paper clips according to its programming. If, on the first day, the robot produces 5 paper clips, we can find out, using geometric progression, how many it will produce on the 10th day. But what will be the total number of paper clips produced in the whole month? Let's find out and show how we use geometric progression for your business. Let's represent the number of paper clips produced on the first day as B1, the number produced on the second day as B2, and so on. If we represent the number of days of production as N, we can work out the number of paper clips produced over any period of time as follows. Let's look at a period of 20 days. N equals 20, so we have this equation. This being the total number of paper clips made in 20 days. The string Bn, where n larger or equal to 1, is a geometric progression of any term, starting with the second and being equal to the precedent multiplied by a non-zero real constant called the ratio of progression. If we give k the values from 1 to n and multiply member with membership, we get. This gives us the relation, which is the formula of the general term of a geometric progression. With this formula, we can find the number of paper clips produced of any day of the month if we know how much the robot produced on the first day, the first term of progression, and the ratio, programming mode. A non-constant string is a geometric progression if, and only if, the sum Sn equals b1 plus b2 plus bn, the first in terms, is given by the relationship. We have the reciprocal of this. With this formula, we can find the total number of paper clips produced in our production unit from the first day to any day of the month, including the last one. This type of data will be very important if we want to be sure we can supply all our customers at any given point in time.